Alright, number 4, we want to classify each of the following statements as true or false, where A and B are whole numbers. So A says if the greatest common divisor of A and B are 1, then A and B cannot both be even. Okay, that would be true. If they were both even, then they would have a greatest common factor of 2 at least. And so true, it says then either A or B is equal to 1 and thus cannot both be even. This one says true, A and B have no common factors other than 1, which implies they do not have common factor of 2. Okay, so it would be D. B says if the greatest common divisor of A and B equals 2, then both A and B are even, and that would be true. No odd number is divisible by 2. So C says true, if that's equal to 2, then both A and B have a factor of 2 and thus are both even. D says true, both contain a square of a number. Since all squares are even, both A and B are even. C, not D. And then C says if A and B are even, then the greatest common divisor equals 2. Okay, that will not be true because we can take, say, 4 and 8, okay, which are both even. A small example. And the greatest common divisor of these two would be, let me just do it like this. The greatest common divisor of 4 and 8 would be 4, because both of these are divisible by 4. So we got two even numbers whose greatest common divisor isn't 2, so therefore it's not true that if they're even, their greatest common divisor is going to be 2. So we have B and C that say false. B says if A and B are even, then both A and B have a factor of 2, yes, but they could have other common factors that is greater than 2. That sounds great. C, if A and B are even, greatest common divisor of A and B will be half of, or half of A or half of B, which in most cases will not be 2. Not sure, that don't sound right, so B.